Problem 7-8. Starting from rest at t equals 0, a 5 kilogram block is pulled along a horizontal surface by constant horizontal force having a magnitude of 12 newtons. If the coefficient of friction between the block and the surface is 0.2, at what rate is the 12 Newton force doing work at t equal 5 seconds? Rate of work is going to be power, so we're going to be interested in force times velocity. So we're going to have to find the velocity of the block at t equal 5 seconds. Here's our situation for a free body diagram. We're going to have this force pulling on it equal to 12 newtons. There will be a frictional force against the motion. We don't know what that is yet. And of course we're going to have weight equal to mg and normal force going up. And presumably this thing will accelerate to the right under our net force. So that is our free body diagram. We want to use this to find out what the frictional force is. Now we know that the looking at the y direction, there is no net force. So that's the normal force minus the weight. In other words, the normal force is equal to the weight, equal to mg. And in turn, the frictional force is equal to mu times the normal force. So that is equal to mu times mg in this case. So that's going to be equal to 0.2 times 5 kilograms times 9.8, which is going to be equal to 9.8 newtons. So that is the frictional force, 9.8 newtons. Nice to know. Now if we look in the x direction, we do have an acceleration. So that's equal to mass times acceleration. And that would be equal to the net force in the direction of that acceleration, which is going to be our pulling F force, minus this frictional force that we just calculated. So we would get that the acceleration then is equal to the pulling F force minus friction divided by the mass. 12 newtons minus 9.8 divided by 5 kilograms, and that's equal to 0.44 meters per second squared. That is our constant acceleration in the x direction. Since it's a constant acceleration, kinematics apply, and our velocity at this point is going to equal our initial velocity plus the acceleration times time. Initial velocity, we started from rest, so that's 0, and hence our velocity is going to equal 0.44 times 5 seconds. So at the point of 5 seconds, our velocity is going to be equal to 4.08. No, 2.2 meters per second. So that's our velocity after 5 seconds. Now the power should be equal to our force dotted with the velocity. And they're both going in the same direction. So we are going to have, that's the force times the velocity, cosine theta. In this case, it's going to be 12 times 2.2 cosine of 0 degrees. Cosine of 0 is going to be 1. And this is going to be 12 times 2.2, which will give us 26.4 joules per second, or watts. So that is the power, the rate of the force doing work, 26.4 watts on the block.